In this lecture, we'll cover the properties of matter. So the objectives for this lecture, be able to define mass. Mass is how many molecules something has, or basically the amount of matter that something has in it. We usually measure mass by weighing something because gravity affects mass, and we can determine how much mass is there by gravity's effect on nearby mass. Volume is how much space something takes up. We are going to cover extensive and intensive properties in another slide. A substance is anything that has a uniform and definite composition. So like carbon dioxide is a substance, water is a substance, liquid mercury is a substance. We are going to discuss physical properties in a little bit, as well as solid, liquid, and gas. And physical change is anything that is going to make a solid transform to a liquid to a gas, or a gas to liquid to solid, or solid to gas. Basically, any change in one of the physical states. Be able to identify changes in a substance when thermal energy is added or removed, and be able to identify how molecular structures are important in the functioning of materials. Both of these objectives are on NGSS standards, and you can expect they will probably be on the test. What is matter? Well, matter is anything that has mass and takes up volume. So those are the basic properties of matter. But we know full well not all matter has the same properties. Some of you may be looking at this photo and saying that looks like wood, or that looks like rock, or something like that. And if so, you could determine what type of matter it is by the properties of that matter. So us scientists, we are going to be looking at different types of matter. And in this lecture series, we're going to be determining what the physical properties and chemical properties of matter are. In order to describe matter, we can use two different sets of properties. First off are extensive properties. This depends on the amount of matter in a sample. So the mass of a bar of steel depends on the size of the bar of steel, or basically how much steel is in the bar of steel. This is true as well of the volume and the size of the bar of steel. They depend on how much matter there is. These are extensive properties. Intensive properties are going to depend on the properties of matter in a sample. So does that steel absorb light? No, it reflects it. What is the color of the steel? Well, that depends on what colors of light it reflects. And what are the melting points and boiling points of steel? Very high, but these are all intensive properties of that bar of steel. There are three states of matter, and these are the physical states of matter. These are physical properties, just like extensive and intensive ones. The first one is a solid. This has a definite shape and volume, usually the highest density for a substance. That would be the ice in this iceberg, which is not actually the highest density of water, so kind of a weird example there. Then there is liquid, which takes the shape but not the volume of the container. Liquid stays at the same volume but takes the shape of the container. If you were to grab some of the water from the ocean in a bucket, then that will be bucket-shaped water at that point. But it will be a set volume, and if you pour that bucket of water into a fish tank, it will become fish tank-shaped water. The gas will take the shape and volume of the container. Gases expand in order to be as large as the container they are put in. We can see gas in the air here. Well, actually we can't, because the clouds are condensed liquid technically. Yes, clouds are more complicated. But we see the three states of matter of water are in this picture. Temperature affects what phase something is going to be in. The more heat we add to a substance, the more it's going to melt and then evaporate. Temperature is the measure of the average kinetic energy of a molecule. So you can see these little blue things. That is a bunch of molecules that are all packed together in a solid. They have low kinetic energy. They are not moving. If we took a bunch of marshmallows and packed them into a box, on the bottom of the box only, that would replicate a solid layer of marshmallows. If we started sloshing them back and forth such that they have a higher rate of movement, that would be a liquid. If we close the box and just shook them very quickly, they will have the same volume of the box. Basically, there will be marshmallows in every bit of the box at some point in time, and that would be a gas. So increasing the temperature is increasing the movement, and increasing the movement changes the phases, whether it goes from solid to liquid or liquid to gas. Lowering it is going to do the opposite, bringing gas to liquid and liquid to solid. So do note these changes in the physical substance when heat is added or taken away.